single day this week, I'm going to give you a new formula. Today is 8-1, tomorrow is 8-2, Wednesday is 8-3, and there's a new formula for every single day that you have to have memorized for your quiz next Tuesday. Now, Thursday we're going to do a volume activity online. Monday we're going to do a worksheet that's like a practice, Tuesday of a quiz. Next Wednesday is the end of the quarter. So your Chapter 8 quiz are the last points of this quarter. So if you want to maintain, if not improve, you're going to want to make sure you put in time on this. None of us want our grades to drop, agreed? So make sure that you're putting in the time. Okay? This calculator, your Desmos calculator, is what you should be using. And I'm going to go through the steps of all of it online with you today so you know exactly how to use it. Okay? All right, page 590, we're going to start right in that paragraph with our information here. Volume is the measure of the space occupied by a solid. It is measured in cubic units, whether it's feet, meters, liters, whatever. It's cubed, feet cubed, meters cubed, centimeters cubed. A cylinder, you guys know as a can, is a three-dimensional figure that has two parallel, meaning they'll never touch, congruent, meaning they're the same size, circular bases connected by a curved surface. The area of the base of the cylinder tells you how many cubic units is in one layer, and the height tells you how many layers there are. This formula right here, V equals pi radius squared height, you have to have memorized. Today, I am requiring that you write that on every single problem for homework, or I will not give you credit tomorrow. And I know that seems like a pain in the rear. However, you're twice as likely to remember something that you write than just something that you hear. So the fact I'm making you write it over and over, nice shoes, is because I want you to remember them. New? I was going to say, I've never seen them before. I like them. All right. Radius. Pi is just a number. Radius is the distance from the center of your circle to the outside edge. The height is the distance between the circles. A lot of people say, well, like, height is how tall something is. Well, until I rotate my cylinder on its, lay it on its side like this, then the height is not how tall it is. So your height is always the distance between your two circular bases. All right, example number 1, just like they have. Every single problem today, you are going to write V equals pi radius squared height. Then we look over at our picture. Pi is a number, so it stays pi. Radius is the distance from the center to the outside edge, so radius squared, and our height is 8.3. Your problems today are going to have 3 lines of work. 1, just the formula. 2, filling in the numbers, and 3 will be the final answer. Now, go to your calculator. How do I type this in? Okay? Because pi is irrational and it's a long, crazy decimal, I want to type pi in last. So the other part of our formula is radius squared and then times height. What was our radius on number 1? 5. So we're going to type a 5 and then hit that squared button in the upper left corner and then make sure you hit enter. You should say 25, yes? Now, I need it to keep 25, so I have to use the ANS button right here. So it says take my answer from before, and then I'm going to take it times my height, which was, what's my height? 8.3. Hit enter. And then last but not least, I need to take that answer again, ANS, times, and then there's the pi button over here. Enter. And you get a long decimal. The directions tell us to round to the nearest tenth. Tenth means one number after the decimal point. So 651 stays, and then I go, okay, 8. I look next door. Is 8 big enough to round 8 up? Yes, so it becomes 651.9. Okay. On number 2, just read number 2 problem to yourself real quickly. What's different about this problem than the last one? What word is different? Nope. Jacob? Diameter. Previously, we were dealing with radius. Diameter is edge to edge on a circle. So if they give you the diameter, the very first thing you have to do is divide it in half. Because my radius is 8, and that's why my 8 goes in my formula. So if I want to say there's a tricky piece to today, is making sure you read carefully that you use your radius, not your diameter. All right, enough looking at examples. Let's do this together. Got it, A. Find the volume of each cylinder, round to the nearest tenth. First thing Ms. Hoff wants you to do, write down the formula. V equals pi radius squared height. Step number 2, fill in the numbers for radius and height. V equals pi, what's my radius? 3 squared, what's my height? 1.8. The next line is going to be my answer. So go to your computer. What's the first thing I type in? 3 squared. 3 and the squared button, we hit enter. It says it's 9. Now I want to use that 9. What button do I have to hit? ANS, answer. Then what am I going to do with that 9? Times 1.8. Hit enter. Right now I have 16.2. Which button do I hit first? ANS. And what's my last step? Times pi, enter. I need to round to the nearest tenth. That's one number after my decimal. What would I round this answer to? 50.9. 50.9. What would my label be? Inches. Inches cubed. Volume is always cubed. 3 dimensions. We're talking about space. The amount, it's always cubed. Okay? Got it, B. All on your own. Thad, question.
So you want the original equation to be like our work that we're showing, and then you want B to be our answer, and you want both of those. Like
Everything that's right there, that's everything I want. Yep, those 3 lines. Did they trick you? What do I mean? They gave us the diameter, so the very first thing you should have done is 12 divided by 2 to give me 6 is my radius. Volume equals pi times 6 squared, and my height is 5. Rounded to the nearest tenth, what is my volume? Anybody else agree? 565.5 millimeters cubed. Perfect. Perfect. Good question by Thad just a moment ago. These are the 3 lines of work that I expect to see on every single problem. And I know right now you find this annoying to write the formula out, but tomorrow I'm going to give you a different formula to use, and Wednesday I'm going to give you a different formula to use, and you have to keep track of all of them. If you don't have those formulas memorized, it's going to be a very long test, but really probably a very short test because you have no idea what you're doing, right? If you don't know these formulas, I can't give them to you. So I'm going to make you repeat them to me a lot. Flip the page and go to Got It C in the middle. No, sorry, don't flip it. I'm sorry. It's flipped for me. On the right-hand side, page 591, Got It C. The Roberts family uses a container shaped like a cylinder to recycle aluminum cans. It has a height of 4 feet and a diameter of 1.5 feet. The container is full. How much do the contents weigh if the average weight of aluminum cans is 37 ounces per cubic foot? Round to the nearest tenth. So they're really asking me, how much does it weigh? The problem is we can't just figure out the weight. They give us a conversion, 37 ounces per cubic foot. Well, cubic foot is really the volume. So the very first thing we need to do is we need to figure out the volume of this container that they have. Everybody on your own, read carefully, fill in the radius and the height, and calculate the volume of this recycling container. Now be careful, they gave you the diameter. Diameter is useless to you. The very first thing you need to do is divide your diameter in half. No, I can't give you an extension cord, but if you just slide that desk next to Jacob back, you can plug it back there. So really your radius should have been 0.75 and you squared it and your height was 4. So when you rounded, your volume was 7.1. And what would my label be? Feet cubed. Okay, that's my volume. That's my volume. All right. Now I need to convert that volume into weight. So I need to take 7.1. Don't take the big, huge, long decimal. Take 7.1 times 37. What do you get? 262.7. Anybody else? Now be careful. What's the label on this now? Ounces. Very good. OZ is the shortcut for ounces. OZ. And we only have to do that because it's asking us for the weight. We can only calculate the weight based on the conversion. Question? Nope. On this one, our volume up here was feet cubed, and then we changed our feet cubed to ounces. So your final answer is going to be in ounces. Good question. Okay? All right. Now I really do want you to flip the page. 592, guided practice number 4. Very, very similar to the problem we just did. Read through it, make your calculations, then we're going to go over it together. Number 4. Did you need to divide your 4 in half on this one? Nope, because it's the radius. It's already only half. What did you get as your volume? 603.2 centimeters cubed. Is that correct? Okay. Now we have to change that to grams. So we take this times 3.5. Correct me if I'm wrong, 2,111.2. And then what would my label be now? Grams, which technically you can just put a G on there. On these ones where they ask you to convert, Davion asked a really good question. Those are going to have a different label. Everything else today is inches cubed, feet cubed, meters cubed. And those are worth points on all of your problems. Okay, again, 3 lines of work on the ones that you have to convert, you end up with 4 lines. Any questions about this assignment? Okay, I'm going to let you get started, and then I'm going to go over those first 3 with you, the first 3 with you to make sure you're on the right track. Get ready, because I jump all over. Get ready to write this down. It's not a long assignment. I just jump all over the page. 1 through 3, 1, 2, and 3. 6, 10 through 13, 10, 11, 12, 13, 16, 18, and 19. 1 through 3, 6, 10 through 13, 16, 18, 19. One quick question. If I have a rectangle, like a box, right? Worst drawn rectangle in my life. Let me try this again. If I have a rectangle, how do I find the volume of this? How do I find a volume of a rectangular prism or a box? Very good. Length times width times height. You might need that today. Cool. About 7 minutes, most people have gotten those first 3 done, and I'll check those with you. And then, I mean, keep going, but once I see everybody's done, we will check those first 3. The rest of the hour is yours to work.